Hello and assalamualaikum student, welcome to another video of study with ARS. Today's our topic is valence bond theory. So it was discovered by Hitters and Haeckel, and these are the names of scientists. And in this theory, what does it explains? So it explains the means it will held in which bond and what type of orbitals are required, what will be the spinning position, and what will be the identity of orbital after the reaction, and what will means how many number of bond it will form, and intensity, what will be the intensity of overlapping, and bond strength or bond energy. So let's going with the first thing, that it will be forming a covalent bond. It is only means this is the theory is only valid for covalent covalent bond. So if you look at covalent bond, there are two types of covalent bond: sigma bond, sigma, and pi bond. Okay, pi bond. So this one will be happening in the x-axis, or you may say head-to-head bonding, and this one will be on the side-to-side, means side-to-side. You may say attaching of an orbital. Okay, so there are means such types of orbital in which it takes place, means the bonding takes place, covalent bonding takes place in unpaired electron. So covalent bonding takes place in unpaired, or you may say half filled half filled half filled atomic orbitals. Means in this type, the atomic orbital will be half filled with the electrons. Okay, they will be having a required they will be having a required electron to means stabilize their condition. Okay, so covalent bond used to happen in means the atomic orbitals which are having a need of electron. Okay, so now we are having the spin of electron, means what is the spinning motion is required for the means this one bond to form, and the means the spinning which is required is opposite spinning. Opposite spinning, spin spinning is required. These all are those points which was explained by VBT, valence bond theory. Okay, so means if at the first we required a covalent bond, and covalent bond has two types: sigma bond, pi bond. So there are means types of orbital in which the VBT held. So it held in the half filled it's held in the half filled atomic orbitals. Okay, means the orbital which are half filled with the electrons. Okay, so it's been talking about the spin of electrons. So spin of electron is opposite spinning is required. For example, here we are taking an example like here. For example, this one is one here electron, and this one is the other electron. So means there should be a means inverse, you may say spinning, because if there will be like this, then they will be repelling to each other. Okay, so there will be creating a force which will not align to means attract to means make bond each other. If they will be opposite to each other, then they will be making covalent bond or a sigma or a pi bond. Okay, so after this we are having a number of bonds. Okay, so before that we are having identity of orbital. First of all, we need to go through the sequence. Okay, so identity of orbital. So means, for example, this one is the means the reaction between them will be plus, so the arrow will be here, and the reaction will be like this and like this. So here will be these two electrons, like this thing means they are in opposite. Okay, and this means sharing is called sigma bonding, because they are coming in a head to head sharing. Okay, so this one sharing is called sigma bonding, and in this they both are means attaching together and sharing their electron, and both spinings are means being opposite side. So if you look at here now, so there are means there is a lot of energy, means there was a high energy as compared to when it converted into molecule. There was high energy in compared to this one, because there is lower energy. Why there is lower energy, I will tell you now. Cause is this, that when they were means separated, they were having a means repulsive force, but when we means gave energy to them, then they combined together by some time, and at the time they combined over means each other, and they shared electron. So at that time there was a means a lower energy than the atomic orbitals. So that is why the identity of the orbiter used to change with the energy. So means first there was a high energy, and then there was a lower energy. So means identity of orbital will be means overlapping, and means energy will be changing will be here, overlapping with delta E would be there. Okay, delta E would be there. Delta E means change of energy. So how many number of bond covalent bond may form, means an orbital can form. So number of bond definitely depends upon the unpaired electron, means depends upon the unpaired electron, and upon the unpaired means how many electrons are unpaired in an orbital. Okay, so it depends upon the means unpaired electron. Okay, so if means for example hydrogen is having one unpaired electron, and the other one hydrogen is having also one unpaired, so they will form one bond. For example, let's look at the example of carbon. So carbon is having means 2 and 4. This is the means atomic number of carbon, and they are having 4 in the valence shell. So the carbon require 4 more electrons to means complete the shell, and 4 are unpaired here, so they will make 4 bonds. Okay, so according to this example is there, the carbon example. So now let's look at the intensity of overlapping. So how huge this overlapping may have. So for example, this is the nucleus of an atom, and this is the means outer part, and this is also a nucleus, and this is the outer part. Okay, so means one electron is there and one electron is there. Now if they wanna means share their electron, then what they will be doing, they will not be doing it like this, means like this. Wait, this is the nucleus, and they will not be touching at the means nucleus. So this one is a wrong one. Okay, we'll draw the full. This one is the wrong concept. Okay, these nucleus will not be changing their position, and these nucleus will not be means touching with the orbital. So it will be like this, which I am drawing here, means like this. This is the p orbital plus another p orbital, then they will form like this. Okay, or they may form like this. This one is the pi bond. Okay, so they are sharing electrons with each other. Or if you look at 1 2 means round example, so it is like this, and they will be sharing like only here till here, 1 2. Okay, so this is the means H2 molecule. So it will be handling apart from nucleus. Okay, and the means they will be sharing electrons each other. Okay, means without contacting with the nucleus. So if you talk about types of overlapping, then I will be answering that there are total three types of overlapping. Then you will be saying that how and which are those. Then I will be saying you like this. First of all, there is a SS orbital. Okay, in hydrogen molecule we are having one electron in the valence shell. Okay, hydrogen molecule, and there's one more hydrogen molecule which is also having one electron. Now they want to make bond, so as you know that S orbital is having a round shape. So here is one electron plus there is another spinning is opposite is per valence bond theory. And when they will be combining, now first of all they are having a high energy, and if they want to make a molecule, so they have to lose their energy. So it will be like this: one electron, two electron. Okay, and the nucleus will be here. No, this is the orbital. Okay, sorry, my mistake. So okay, so means this is the SS orbital sharing, and it will be holding with only the atom of hydrogen. And then where we are having sp orbital, so here it will be holding means with like we're taking an example of hydrogen fluoride. So means a fluorine is having a 9 atomic number, so it will be like this, 2 7. And if you know that 1s, let's look at the means electronic configuration: 2px, 2py, 2pz. So according to the Hans rule, we have to fill it by one. Okay, so 1 2 3. So now means 2 are here, 2 are here, 4 5 6 7, and 2 more required. Okay, 8 and 9. Okay, so this one is the means free electron. Okay, and it requires one more electron, then it will be making bond with hydrogen. Hydrogen is having only one one electron. So when they will be making bond, so this one bond will be called between this bond is between S and P orbital, and this bond will be called as sp orbital. This overlapping is will be called as sp overlapping. Okay, the bond will be depending upon the means is it happening on x-axis or y-axis. So that bond depends upon the axis. Okay, that is it a pi bond or a means other bond. So here we are having pp means overlapping, so it will be holding between the pp orbitals. So let's look at the means again the example of fluorine Fl2. They both need one electron to complete their outer shell. Okay, so the means electronic configuration of fluorine is here, you may say, and you may see. Okay, so now here we will be drawing the structure. So means this one is the p, so this is the first electron, and this one is the another electron. So when they will be sharing their electron, this bonding will be called pp overlapping. So hope you guys enjoyed this lecture. We'll see you in the very next video.